Resolution of vector. The process of splitting of a vector into two or more than two component vectors, in different directions, which together produce the same effect as is produced by the single vector alone, is known as the resolution of vector. Resolution of a vector. Resolution of a vector is equivalent to splitting of a vector. Two or more than two component vectors. Splitting of a single vector into two or more than two component vectors, and the component vectors will produce the same effect as is produced by the single vector alone. There are two types of resolution of vector. There are two types of resolution of vector, of a vector. Number one, resolution of a vector in resolution of a vector into two or more than two components, two component vectors which are perpendicular to each other, which are at right angles to each other. For resolution of a vector into two component vectors, we denote two different directions, and we can draw a rectangle and the diagonal. Along this diagonal of this rectangle, a vector is expressed in magnitude and direction by that diagonal, and we can denote the x-axis and y-axis in mutually two perpendicular direction. Vector A acts at an angle alpha with x-axis and it acts at an angle beta with y-axis. Now vector A is resolved into a component vector AY along y-axis, and vector A here vector A is splitted into two component vectors, two components, vector AX and vector AY, at an angle alpha and beta with vector A such that vector AX, vector AY is perpendicular to vector AX. Component along y-axis, that is vector AY, will be perpendicular to vector AX, and alpha plus beta equal 90 degree, because vector AX is perpendicular to vector AY. Alpha plus beta is equal to 90 degree. Now we can go to the next page. we can draw three mutually perpendicular axes x, y and z axis in 3 dimension, and a vector A is denoted by the straight line OA in magnitude and direction. Vector A is denoted in magnitude and direction by the straight line OA. The component of vector A along y-axis is vector AY, component of vector A along x-axis is vector AX, component of vector A along z-axis is vector AZ. In this case, angle subtended by vector A with z-axis is gamma, angle subtended by vector A with x-axis is alpha. An angle between x and y-axis is 90 degree. Similarly, angle between z and y-axis is also 90 degree, angle between z and x-axis is also 90 degree. Number 2, resolution of a vector. Resolution of a vector into two or more than two component vectors, such that these component vectors are not perpendicular to each other. Vector A is, for this we can draw a parallelogram. A vector A is denoted by the diagonal of the parallelogram. O is the origin, and vector A is resolved into two components. Vector A1 is the component vector along x-axis and vector A2 is another component. Alpha and beta are the angles subtended by vector A with vector A1 and vector A2. Here vector A1 and vector A2 are the component vectors of vector A. Vector A1 and vector A2 are the component vectors which are at an angles alpha and beta with vector A, such that alpha plus beta is not equal to 90 degree. That means vector A1 is not perpendicular to vector B2. Vector A1 is not perpendicular to vector A2. Alpha plus beta not equal 90 degree. Hence, vector A1 is not perpendicular to vector A2, means two components are not perpendicular